Okay, back to that. So anyways, the key thing here was setting VF equal to 0 at the top. This equation knows that there's only one spot in reality in this using this equation where D or VF is 0. Because nowhere else in this trip would VF be 0, right? On the way up to that peak, it's some positive value, right? It is slowing down towards there, but it's some non-zero number. And then once it starts falling down, you have non-zero negative numbers, right? So by plugging in VF equals 0, we just got to realize that we're essentially telling the equation to solve for the maximum height it could reach, because that's the only place that happens. So VF is 0. We plug that in, rearrange, subtract over VI squared, divide by 2D. Take our numbers, 22.5. Don't forget to square it over 2 times. Oh, that should be G, not D. I'm sorry. That's a G. 2 times negative 9.8. Solving for D. And the negatives will cancel, which they better because our maximum height's going to be up, right? So they better get a positive number, which means above, up here, above from where we started. So that's going to come out to about 25.8 meters. Okay with that part? All right, part B. How long does it remain in the air? And it gives you a similar hint that I gave you. Hint, the time it takes the ball to rise equals the time to fall. But remember, in this condition it does, right? Because it came back down to the same point in which we threw it up. If we did something like this, and then caught it down here, we couldn't use that symmetry, could we? But because it did do that, we can say that. So we're going to attempt to use only givens. We're going to always say that, right? So we're going to still try to use this and this, but this time find t, right? But what we got to realize is if we use only givens, that this will find just the t on the way where? Yeah. Actually, technically on the way up, because we're starting with the VI from down here that we threw it up with and it's stopping here, right? It is the same, but technically we are finding on the way up because our VI is positive, right? Okay. But the main thing we got to realize is when we find this t, we haven't fully answered it yet. What do we got to do to it? Because it asks us for the total time in air, right? How long does it remain in air? So what do I do with this t that I solved for? Yeah. Multiply by 2. Just don't forget to do that. Realize we have to do that. All right. So using those givens up there, we would use equation 1, which says VF equals VI plus GT. VF is 0. Therefore, T equals, we'll subtract over the VI and divide by G. So that would be negative 22.5 divided by negative 9.8. And we should get about 2.3 seconds. So we need to double that for the total time. So that's how we get 4.6 seconds. You okay with that one? Does anything make sense there? I'll say something and I'll re-explain it. You all good? Any others we have questions on? Yeah, Ethan. 46? Okay. It's similar to this one, but there's a really important thing we're going to point out in this one, especially for part B. It's actually, part B of 46 is asking the same thing here, but the givens are different, which makes us have to rethink it. So again, we're throwing something up in the air. This time we're flipping a coin to determine whether you do your physics or English homework first. That's a no-brainer. You don't even need a coin. Like, obviously, we're just going to throw the English in the trash. The coin is flipped straight up. The coin reaches a high point, so we know it's flipped up, thrown up, however you want to say it. Negative 9.8 meters per second squared is one thing we know. It reaches a high point of 0.25 meters. So this time it does give me like that peak, right? And that stays positive because it's the high point up 0.25 meters. And the first thing in part A we got to realize, other than what it's asking me for, which is what's its initial speed, we need to solve for VI. Obviously, we don't have enough information unless we extract one more thing that isn't directly maybe jumping out at us. 0.25 meters is its high point. So because that's its high point, what else do we know? What do we have to infer about that? Anything? VF is 0. Make sense to everybody? Remember, that's high point, it has to stop. Alright? So if we want the VI it was flipped at, that's going to be the VF where it stops up there for a moment, right? Once we know that, shouldn't be a big deal to solve it. We again go to equation 3, which is VF squared equals VI squared plus 2 times G times D, with VF being 0 again. Solving for VI this time, we'll have to subtract over 2GD, take its square root, and since we're square rooting something that's a vector quantity, our answer could be plus or minus. Now, for this situation, though, and what's being asked, what should I pick on my answer? Is it going to be the positive or the negative version of this number? We're looking for VI that we flip that, Sarah. Positive. That's going to be going up initially, right? So, plug in the numbers, pick the correct sign one, which is positive. Negative 2 times negative 9.8 times 0.25. Run those numbers, and we should get an initial velocity that should be around 2.2 meters per second. You okay with that? Alright, so the problem, more than likely, on this one usually comes from part B. This is the first time this probably happened in any of the problems I've assigned you, so we probably haven't realized yet, so let me ask the question first. Look at all 4 of your kinematic equations, wherever you have them written down. There's one variable, one specific variable that appears in all 4. It's the only one that appears in all 4. What is it, Ethan? What's that? Nope. I was missing one of them, Sarah. Initial velocity. And that gives us a little bit of a problem in this one until we think a little bit. Because I'm just going to, just for the point of having it here, you don't have to relist your givens if you have some of them over there, but I'm going to just so we have them all in the line again to realize something. So G is still negative 9.8. We're asked to find a total time in air again. Like if I catch this coin at the same height, which I flipped it up at. Alright, so we know we still know we could find half of it and double it, just like we did the last problem. But the issue is here, trying to use only givens, it may seem like I'm stuck for a moment. Because there's all my givens that we just used for part A, right? This time it's asking me for time. If I try to just find the time on the way up, I got an issue, because time's unknown, and we just confirmed that VI is going to be in every equation. And we don't have it given, do we? We have it, but we don't have it given. So any equation I would pick, trying to use only givens, would have how many unknowns in it? 2. You can't solve an equation with 2 unknowns, can you? So does that mean this is unsolvable? No. You could have used this, alright, and if it was right, I'll give you credit. If you carry this through and use the VI you solved over here, that's an option. But remember, we try to avoid that if possible, right? Because if you got part A wrong and you use the answer to part A and part B, then you're going to get part B wrong, right? That's the purpose of trying to use it on givens. Now, sometimes that is the only thing we could do in certain problems. But we could actually get away, if we rethink this, we could get away with just using only givens. Does anybody have any idea how? Goes to something I said yesterday you may or may not remember. We're allowed to segment a problem up any way we want as long as it helps us and we have enough information, right? So all these givens written as is are for the way up, right? Well, didn't we say the time coming down is also the same as the time coming up? What if we consider that for a moment? that actually changes some things. I'll erase something in a second. Let's consider the ball going down instead of on the way up. Well, we gotta relook at every one of our givens. No matter what, G is still negative 9.8, right? That can't change that sign. No matter what, we said that has to always be that. But now, instead of going up 0.25 meters, we're going down 0.25. What do I need to do to that number? Yeah, make it a negative if I'm going to view on the way down. And now my VF isn't 0, is it? What's 0? Yeah, VI. And we just solved a little issue, didn't we? Remember we needed VI? Viewing the problem on the way up, that was an issue because all those formulas have it. But if I view it on the way down as if it was dropped from up there because it stopped, VI 0, isn't it? Now I could use one equation using only givens if I make those adjustments, can't I? Now I could solve for t, and I'll still have to double it because it'll just be just the way down, not both, which we need the total time, but it shouldn't be a big deal. So if I pick equation 2, which is d equals VIT plus 1/2 GT squared, VI now being 0 gets rid of that part. Rearrange to solve for t. T is the square root of 2d over g. Mathematically, this step is why we had to make that d negative. Although it makes sense to, too. But if we didn't make that negative wouldn't cancel out with this negative of the 9.8, and we'd have to be stuck because we'd have to try to take the square root of a negative, which can't happen. So that takes care of it as long as we made that 0.25 going down negative. This t comes out around, depends how you round it, but you're probably going to get close to 0.23, okay? So that's not the total time, that's just the time going down, so we double it in order to get the total time. So that's the best way to do it, because I didn't have to rely on something I already solved for, right? Cool. Question? Yeah. Right there? I will say this on a test or quiz, if you did it the way by solving for the VI and using the VI, I'll give you credit. I'm not going to take off as long as you get it right. But like I said, you can get something early wrong and keep using it and don't necessarily have to. That's going to keep getting you wrong the whole way through the rest of the problem. So, if possible, try to use only givens. You can make it work. Any other questions? Yes. 40 what? 44 did you say? Okay. Alright, it says a student drops a ball from a window 3.5 meters above the sidewalk. How fast is it moving when it hits the sidewalk? Alright, so we drop, that means VI 0, right? As long as we can assume we're dropping some a stationary place, which we are. And free fall, obviously, negative 9.8 meters per second squared. And we've got 3 meters above the sidewalk. But it's going to fall down that 3.5 meters, right? So we've got to make that negative. And we want to find the velocity upon striking the ground, the final velocity. Now, a few people asked me this, but I did state it yesterday. Does that mean after it strikes and it stops? No. We wouldn't make a problem if that's all as simple as it was. Of course, eventually it's going to stop after it hits the ground. When it says, words it like this, how fast is it moving when it hits whatever, the sidewalk, the ground, whatever, that's its maximum speed upon contact, which is VF, okay? For a non-zero VF, we got to solve for it. So as long as we got our given right here, there's nothing else to it. So we go to equation 3 again, and all we got to do to isolate VF is square root each side, and that's 0. So VF will be plus or minus, when we square root, 2 times G times D. We are going down, so it would be sensible to make it the minus version of it, right? We're on the way down when we hit that ground. So 2 times negative 9.8 times negative 3.5. Run those numbers, take the square root, and that's how we get. We do get negative 8.3. This is what I was talking about earlier. However, it just does ask how fast, which really represents just the speed. So technically, just the speed is the magnitude, the number part. But if you gave me the negative, that's even better. You're not going to be taken off for giving me more than enough as far as direction goes. So as long as you at least gave me 8.3, that's all that matters the most. If it said find the velocity when it strikes, you would have definitely had to include the negative. We okay on that one? Good. Any other ones? Okay, this was the last new topic of this chapter, so here's how the next few days is going to go. The lab's going to take tomorrow and more likely into Friday. So I already posted on Classroom all the review problems for this chapter for a test. You have a week to do them. There's 15 problems, but that's not a lot unless you wait till the night before to do them. They're due on Wednesday. We're going to go over them, any questions we have on Wednesday. And then test is Thursday. All problems based, just like the review. All right. But there's 3 general categories of problems we have. We got the most basic kind that were on the quiz you just got back, right? That's the first kind we ever did. Most of those were like on this axis, right? Or an incline, but they were similar enough. Then we had the 2-part problems, right? And now we have the free fall. There'll be a mix of problems on the tests, just like there's a mix in this set. You've really got to pay attention now because they're not given in little group sets anymore. All right? So I'm not giving you ones where I'm telling you, hey, these are 2-part problems. You got to be able to read it and realize it. Don't forget, when it's a 2-part problem, if you read it carefully, one part's going to have constant velocity, one part's going to have acceleration, right? You come in any order. I will warn you, on the test, if I give a 2-part problem and you don't pick it up as a 2-part problem, try to solve it with one equation, you're going to miss a lot of points. All right? A 2-part problem had a lot more steps than some of the other problems, right? Therefore, they're going to be worth more points. And if you barely do any steps trying to solve it because you don't correctly identify it as a 2-part problem, you can miss a lot of points that way on one single problem. All right? Then we'll have the free fall problems we just did, so that's all fresh in your head, being able to identify free fall. So essentially like 3,000 problems, but they're all very similar. All equations will be given, just like on the quiz. Any of that might be necessary. So to speed things up on Wednesday, so you know coming in which ones you have to ask, I posted, where was it? Here's the review problems. You don't have to write them down. They're on Classroom. All right, there's the 15. They start on page 81. But you'll notice if you scroll down, I posted all the final answers. Like always, I just rip these from the book, so they're sig fig ones. As long as you're really close to those, you're fine. So that way, as you do them, you know if you're getting them right, and you know which ones to mark to ask. I'm not checking these for correctness. I'll do a spot check like I did today. All right, as long as it looks like you gave an effort and have work attempted, even if you didn't get it right, you'll get whatever points I make this. Do a spot check. So, come Wednesday with questions. Tuesday, we're going to, you guys aren't here Monday. Tuesday, I'm going to give you a few concept builders on free fall just to kind of end a little bit with that. Okay? Do those. That should be easy, like 15, 20 points. So those are all there. Just again, I highly suggest you don't wait till the night before to do 15 problems. All right, do a little here, do a little there. That's why I'm giving you about a week. I won't give you any other problems between now and then either. Okay, just leave one. All right, so with a little bit of time we got, I'm going to introduce the lab we're doing tomorrow, so we can kind of get started right away. All right. So I also posted that. I thought I did. Hold on, I got to real quick.